Okay, welcome to 7.1 Graph, Exponential, and Growth Functions. We're changing gears now and we're going to start talking about different functions that are non-polynomials. So this function is not a polynomial because if we look at b to the x, okay, we don't know that exponent. It's just a variable, so we don't know it. It's not a polynomial function. This is called an exponential growth function, and our b value has to be greater than 1, and we're going to notice that if it's not greater than 1, we don't have growth, and we also wouldn't have at some point an exponential function. Let's say if b was 1, then you just have 1 to whatever power, and you would have just a horizontal line. So b has to be greater than 1. This is the parent function. We've talked about parent functions being the simplest form of any function to graph. The general shape, we increase from left to right, and when you have just the b value here, b to the x, the 2 points you can plot are 0, 1 and 1 comma b. So this right here is important because it gives us a quick way just to get 2 points on the graph and then draw this thing. So the other thing you need to know is that we're going to get really close to what's called an asymptote. It's a horizontal line. In this case, it's the x-axis. So the one thing you have to pay attention to is that this asymptote is directly related to your k value. So later on, we're going to translate these functions, these exponential growth functions, right and left and up and down. So that asymptote is going to play a big part. Domain of this function is all real numbers, and the range is y is greater than 0. Think about it. This blue graph is nowhere in the negative y range, so it's just greater than 0, and it's not including 0 because we don't touch the axes. To write these in interval notation, we're going to go ahead, and the domain would be negative infinity to infinity with parentheses because we can't include that, and when you write the range y is greater than 0, we would say 0 to infinity, and those are interval notations for this range. So what we're going to do today is we're going to graph several of these functions, and then we're going to make another video dealing with compound interest and another type of exponential growth function. So let's go ahead and do that. So here is our function, our first one, example 1. Graph this simple function. Okay, in this case our b value, if you want to identify it, b is 2. From the previous page, we know we can plot 0 comma b. Okay, and we also can plot 1 comma b. Well, not 0 comma b. I made a mistake there. That should be just 0 comma 1 because anything to the 0 power is always 1. So let's just follow this pattern here. So we're going to plot 0, 1. Okay, so 0, 0, 1. And 1 comma b. Our b value is 2, so we're going to plot 1 comma 2. Doesn't look exponential right now, but if we kept going and adding values, let's say we put 2 into this function. F of 2 means 2 squared. 2 squared is 4. Okay, so now it's starting to change, and if we plugged in 3, we'd get 8, and that would be, up here somewhere. So now you can see it's starting to go up. If we plugged in -1, we'd get 1/2. Now, do you need to plug all these values? No, you don't need to plug all these values, but let's see if we can get all these points. There we go. These are really the primary two you need for b to the x. Notice how our domain is still all real numbers, and our range is y is greater than 0. So that's our first glimpse of this function, 2 to the x. Okay. Now we have two more equations here, and I want to highlight this graph here. We've changed our a value. There's an a value here. So these next two examples are just really f of x equals ab to the x. Okay, in this case a is -1, and in this case a is 1/2. Okay, so how does that affect our graph? Well, when a is negative, we'll get there, we're actually going to flip the graph over the x-axis. Just like with quadratics or any polynomial, we change the output values. Now when a is 1, we can actually plot 0 comma a. Okay, If we plug in 0 for x, that just makes this whole thing 1. And then if we do 1, we just have to do a times b. So those are the 2 points. It changes a little bit, but we can just use those 2 points in graph. So I'm going to go ahead and just do that, just these 2 points. Okay, so we have 0 comma a, that's 0 comma 1/2, right about there. And 1 is a times b, so 1/2 times 4 is 2. Now I could add more points here if I wanted to. I could plug in 2 for x, and you'd have 16 times 1/2, which would be 8, somewhere up there. And I'm going to follow the asymptote and draw my graph. Okay? Again, the domain, all real numbers. Range, 0 is 0 to infinity. Y is greater than 0. It doesn't change. Now here is where we're going to change the range. Okay, a affects the range. So we can still use this idea 0 comma a. So a is -1, so you'd plot 0 comma -1. And then 1 comma a times b. Well, a is -1. -1 times 5/2 is -2.5. So that's right about here. And notice how for the first time our function is below the x-axis. The asymptote still stays the same. It's still the x-axis, okay? And that probably will curve more this way. Let's try just to make that a little more accurate for you guys. I apologize. So we'll hit these 2 points, and I'll go down like that. Okay, so let's just make a note of the range. The domain is still the same, but now it's not from 0 to infinity. It's 0 to -infinity with parentheses. Again, interval notation here. Okay, now that's when you have an a value other than 1. Okay, so we've started with, let's just recap real quick. When a is 1, you have b to the x. 2 examples now where we have a is other than 1. We have a fraction here and a negative here. Now what we're going to do is translate these functions. So now we're going to throw in h and k. But it's actually quite easy. Think about h and k. This is the general translations of, this is the translation equation right here. Okay, h and k affect the function the same way. H is going to move left and right. K is going to move up and down. So you actually start by plotting this function. Okay, ignoring h and k. Once you do that, once you have those points plotted, then you move h units horizontally, k units vertically. So let's look at this example. It's not terrible. We're going to graph this function and state the domain and range. So first let's identify a. A is out front, so there's a, it's 4 times, our b value is 2, and we're going to plot 4 times 2 to the x. That's the parent function of this translation. So here's a, here's b. Let's use 0 comma a point and 1 comma a times b. So 0a is 0, 4 right there. And 1 is a times b, so 2 times 4 is 8. So that's up here. So that might be tricky to plot, okay? So let's go back and we try -1. We can plot another point. So -1 would make 4 times 1/2. So that's just 2. And if we plug 2 in for -2 in for x, we get -4. 1 4 times 4, which is 1. And this is the parent function. Now, first thing we should talk about, the translation. H is this value right here. You're subtracting off 1. Take away 1. So we're actually moving right. So you want to be very careful. And that is, so we're going to move right 1. Okay? And we're going to go down 3. Now, we talked about the horizontal asymptote being the x-axis, but now look at k. K is -3, so our new horizontal asymptote that we're not going to cross is -3. So I'll draw that in real quick. So now just move your points. 1 right, 3 down for every point. So 1 right, 1, 2. So 1 right, 1, 2, 3 down. 1 right, 1, 2, 3 down, and that's good enough. Okay, and you should see it. It looks like it goes 1 right, 3 down. The domain is all real numbers, But let's look at the range. The range now is from -3 to infinity. The graph is going up. It's not below that asymptote line, so we're going to go to infinity for the y values. So that's the first part of this lecture, graphing exponential growth functions. And so hopefully you have a better understanding of that. In the next video, I'm going to show you a couple real-life situations where we actually use these exponential growths.